Hey, what's up guys? Welcome to another episode of Pan the Organizer. So today we're talking about graphene coatings. Are they snake oil? Are they made out of tears from a unicorn? Are they made from fairy dust? Are they the real deal? So we're here to debunk some myths, and in a series of videos I'll be talking with industry experts from the R&D departments and the chemists themselves so we can talk about this technology, because I think a lot of information is needed, as this is touted to be the next evolution in the surface protection of the car care world. So basically there was waxes, then there's paint sealants, we moved on to ceramic coatings, and the evolution of that is now graphene based coatings, whether it's graphene or graphene oxide. So there's a lot of misinformation on YouTube, and we're here to set some records straight. So it's going to be a very interesting video, because today we have a special guest. So graphene coatings are made to protect pretty much, well, any exterior surface for now other than rubber. So stuff like paintwork, glass, your wheels, plastic trim, all that kind of stuff. So you've seen them in traditional looking bottles like these. And some brands also started releasing them in a more convenient spray format, so not as much durability. However, you had the trade-off is for ease of application. So you've seen a few already. So are they truly what they seem to be? Is it only marketing ploys? Well, we're going to find out. I'm digging deep. I even asked you guys to provide me some questions to ask the industry experts. So no holds bar. I'm going all in. You're going to absolutely love this. So without further ado, stay tuned. Let's go ahead and start the show. Okay guys, so welcome to a chat with Pan the Organizer. So I'm very lucky today because I'll get a conversation going with David. He's a resident chemist. I'll let him present himself in a few seconds, but basically we are going to talk about graphene coatings. So there's been a lot of talks and a lot of discussions on YouTube, social media, different forums online about this new car care technology. And I recently reviewed a few products on my channel, including 303's new graphene spray nano coating, which is sold out in 24 hours. So clearly there's a lot of excitement behind this. So first of all, David, welcome to the show. Thanks for taking some time out of your day to come and talk with us, because I think it's an important conversation to have. This is a new technology, new to the market, although it's been out, I think, for about a year now in the car care world. However, I think graphene has been out since the mid 2000s as far as technology in the industry and the chemistry goes. So basically, well, first of all, let me introduce you to my viewers so they know who you are. Present yourself and what credentials you have. So go ahead.
All right. Well, thank you, Pan, for allowing me to interview with you. It's really awesome, and I'm happy to be on your channel. And so so my background is in chemistry, also in biochemistry and biology. So I graduated with triple degrees. And when I completed that, that's when I went into automotive car care under formulations. So for the past 12 years, this is really all that I've been doing is formulations. And this is what I love to do. It's a huge passion of mine, just like you.
Absolutely.
Vehicles and going out there and just seeing what can happen and trying to make better what's already been done. That's really what I enjoy doing. So coming out with new crazy inventions is scary, but at the same time, it's very rewarding.
Yeah, it is. And you've been working, so you work for 303 Products, obviously?
Correct.
And how long have you been with the company?
So I've been with 303 now this is actually, I just finished hitting 7 years.
7 years already, okay.
First.
So basically we can say you're like one of the head R&D and chemists over at 303.
Yeah, I am the R&D lab manager.
Okay.
Here at 303.
So I'm talking to the top dog in the lab. I love that. I don't know if you know, but some of my viewers do. I do have university degrees in molecular biology and biochemistry. So I think that's cool because it allows me to understand a bit of the chemistry when you guys talk, and also make my own mind up on things. But what I want to do today basically is ask you a bunch of questions. Now I know 303 cleared me for anything I want to ask you, no holds bar. So please be honest, transparent. I'm going to hit you hard. I know you're laughing, but yeah. And you want to see how ready I am? They don't call me Pan the Organizer for nothing. These are all questions that basically either I have or I collected on my social media accounts because I asked my viewers to participate. I noticed that a lot of people had questions surrounding this basically brand new to the market technology as far as the car care industry goes. And so we're going to try and answer these today. And like Arnold Schwarzenegger himself often says, I'm going to ask you a bunch of questions and I want them answered immediately. So be as honest as you can. I'm going to hit you hard, and there's no editing here. So hopefully you can go ahead and answer. I understand, obviously, that you can't reveal any industry secrets or any proprietary things, but go as far as you can and basically make us understand what's going on. I've seen a few videos out there. I know some discussions have started on a few channels with either industry experts on the topic or some chemists as well. So what I think is important is to get a broader view by while communicating with different people in the field as well, to get different opinions. And that way I think it'll allow my viewers out there to have a better understanding, first of all. So make it simple for them to understand what this technology is all about, and then make up their own minds if they want to start trying it and using it on their own, right? So if you don't mind, let me dig right into it and start with question number one. First of all, I think it's going to serve as a great introduction. So from a chemistry perspective, what exactly is graphene? So I want you to explain basically so everybody can understand in simple terms what it is. We all heard that pure graphene is this 2D superstructure of carbon atoms that's supposed to be one atom layer thick. That is supposed to be super hard, much harder than steel, possibly Kevlar as well. But I hear that pure graphene is super hard to source. It's very costly. So is there actual graphene in graphene coatings? So if you can first start by, the chemistry. What is graphene?
All right. Well, no pressure. Thank you for that's actually a pretty tough question off the bat. But what graphene is graphene is an sp2 hybridized aromatic ring structure. Essentially, it is this.
So like a honeycomb structure.
Correct. And so what you see here is a bunch of benzene rings, basically that are linked together, and those the s orbitals are linked together. So when it is stabilized by resonance, so the electrons are going around this ring structure and is preventing it from destabilizing. And so even though the product itself, it carries double bonds all across the rings, but really half bonds. And so the graphene is powerful due to those sigma bonds, and the bonds itself are considered covalent. And they're extremely hard to break, which is why graphene itself is just as strong, if not stronger, than steel. And you are correct when you're saying that it is difficult to source. I was at a conference earlier this year, and what I found was that there was less than 4 official sources in the United States. And whereas I can't comment on to what other people are using within their liquid products, but if they claim graphene, hopefully that's what they're using or one of its derivatives. And so from what I've learned about graphene is that it has been used to fortify parts of airplanes, automobiles. It's heavily being used in batteries, superconductors, on solar panels, and it's because of the electroconductive properties of the graphene structure. And that has to go back to whenever you look at this molecule, you're seeing all the electrons going from one ring structure to another, and that's really what graphene, in a nutshell, that's what that is.
Okay, so basically, if people look at the chemical structure, for those who don't have a chemistry background, all the peaks, all those spikes there, those are carbon atoms, right? So yes. That's when we talk about the chemical structure. So in the car care industry, then why would graphene be so interesting? Because we've seen a lot of claims, and basically, my understanding is that pure graphene hasn't made its way through into car care products just yet. So it's a derivative called graphene oxide. Mm-hmm. Is that correct?
Yeah, that is.
So you guys never claimed that you're using pure graphene.
No. In our product, we don't claim pure graphene. And in addition to not claiming that, pure graphene itself is extremely difficult to use. So one part is sourcing it, the other part is using it. And pure graphene without the functional groups, which I'm actually going to show the graphene oxide at this point.
Yes.
So all these functional groups on there that you see, those are the OHs.
Yep.
And those hydroxyl groups, and more specifically, they're carboxylic acid groups. But those groups are what allow the product to be able to be solubilized within a liquid. And so pure graphene itself, without the use of chemical engineering, it's rather difficult to use. And having superconductors is not, or actually super reactors is not something that we have within our facility. So when we discovered that there was graphene oxide as an option, we went ahead and went that route.
So, okay, now that we're talking about graphene oxide, so that's my next question. Basically, my understanding is that most graphene coatings are actually made from graphene oxide and not pure graphene. So we just established this. Are there disadvantages of having graphene oxide over pure graphene? Are customers getting ripped off? So your beginning of answer seemed to be like it's more easy to incorporate a graphene oxide into a solution to be able to use it compared to pure graphene. So is that correct? And are there any disadvantages of using graphene oxide over pure graphene?
Well, see, the difference between the two more or less has to do with those functionality groups. Pure graphene is more electroconductive, and again, going back because of the electrons floating all around the molecule. But with the graphene oxide, there isn't any major disadvantages. And it really depends on the application and what the user is trying to accomplish. The graphene, like I said, is more electroconductive than its derivatives, graphene oxide or even reduced graphene oxide. And so if you're coating batteries or superconductors, that's where you want to use pure graphene, but that's really hard to do. Not very many companies have succeeded. But the truth is graphene is also extremely expensive, so the process of using it would be astronomical for the end user. And so then really customers aren't getting ripped off in any way because graphene oxide, the backbone is still graphene. The structure, the base structure is still graphene. So you're still getting the benefits of graphene itself. And actually,
can you show both structures side by side since you do have the plan? Because we're going to see that the backbone, is almost identical.
Yeah. So when you look at this, the graphene oxide, those hydroxyl functional groups, they actually provide more benefits, and it has to do with hydrogen bonding. And so the hydrogen bonding allows for a specific structure. So then the graphene oxide, when it applies to a surface, specifically ours, you'll see it go on as black.
Yep.
And that's because it's disoriented, like there is no orientation of whatsoever. So it's going to go on there and it's going to lay on top of itself and just be however it is that it was sprayed on. And as the product is curing, then that's when the hydrogen bonding will take in effect and it'll start to orientate on top of itself, start to stack. And so when the hydrogen bonding occurs, that's when the product starts to become transparent. Mm-hmm. And you can see it with the application of the product because you'll see it go from black to semi-transparent.
Absolutely.
Like a whitish type color.
Yeah.
And that's when you know you went from liquid to dry to cured.
So for some chemists that I've been talking about, pure graphene, which is basically a single layer of 2D carbon atoms in that honeycomb structure, which leads to that rigidity. Obviously, that's not possible, at least not yet, through chemical engineering in the car care world. But graphene oxide is not quite the same, right? It's not a single layer of 2D atoms. It's more of a 3D structure.
It is a stacked structure.
Yeah.
So it's not going to be a single layer thin. Mm-hmm. But that stacked structure, that's where you get the added benefits of those hydroxyl functional groups and the hydrogen bonding. So for all the chemists out there, then they'll understand hydrogen bonding it's extremely hard to break. That bond is hard unless you introduce some sort of acid or strong base while it's still liquid. But once it's cured, it's not coming off. It's not that bond will not be broken easily.
And so I think a lot of viewers, a question that they have is, for the past 5 or 6 years, we've been using ceramic coatings on vehicles, and those are extremely popular. They have great chemical resistance, they have slickness, they add gloss and depth to the paintwork, they have extremely awesome hydrophobic properties, so the water sheeting, the water beading, and I mean durability. We have coatings now that can go upwards of 5 years of protection. So why all of a sudden a shift to graphene technology? Because for ceramic coatings, one of its Achilles heels was water spotting issues. And that seems to be like a key selling point of graphene coatings. We'll get into that later because I do have a question about that. But in a nutshell, why is the industry the car care industry seeming to move towards graphene coatings when ceramic coatings were so good?
Well, not to knock on ceramic coatings because they are great. I mean, some coatings give you 7+ years of durability.
Yeah.
The benefit to the graphene products, and I'll actually show you. Hopefully, this comes up on camera.
Yep.
This is the graphene oxide powder itself, and the benefit behind that versus ceramic coatings is it also provides you that durability. But as you mentioned, the water spotting. What we discovered here at Gold Eagle was that as soon as we incorporated graphene oxide and we started throwing in some catalysts with a variety of different distillates, what was discovered was we reduced the water spotting tremendously, and a lot of it has to do with there's actually various reasons behind that. And I hope we get into a deep dive behind that.
Oh, believe me, I'll have questions for you on that point.
Yeah, because the one thing that we really want to do, and I love to do it, and the people here at work, they know like geeking out is really fun.
Yeah.
So the difference between the two, they're very similar, depending upon who formulates it and how they put it together, and in the mode of application. But they both provide mutual benefits of durability, strength, scratch resistance to a certain point, and some of them are easy to use, some are harder to use, depending upon whether it's a spray or hand applied. But so there are benefits behind it, and the biggest one has to do with the reduction in the water spots.
So basically all the advantages of current ceramic coatings with additional benefits such as reduced water spotting issues, I guess?
Correct. Yeah, because if you think about it, whenever you're washing your car at home and you dry the car down, and let's say the sun is beating down and you didn't have time to remove the water from the surface. Well, now depending upon the hardness of your water, you're going to wind up with spots. So, and it's all based on the calcium hardness and whatever environmental factors are in your area.
Yeah.
So this product, after it's been applied, and you go to wash your car again, and then when you go to rinse it, the water evacuates really fast. And any water that does remain, it will no longer create those spots. And if it were to create a spot, they come off really easy. Unlike before where you had to use extremely aggressive water spot removers to try to take the areas off or all the metal deposits.
Yeah, I have a good water spot removal tutorial on my channel and can go all the way up to having to compound and polish the surface if they're really etched in there, because you can do permanent damage if you don't address it.
Yeah, that becomes a nightmare. And for the novice, they really don't know what to do.
Yeah.
And that's when, I mean, thankfully there's your channel exists so that way they can go on and figure out what to do. But if they were freaking out in the moment, our product, the nice thing about it was if water were to dry there with their finger, they can remove the water spot.
Okay, so it is possible that they're going to see some traces of water or some mineral deposits left behind even after the graphene coating application, but it's much easier to remove.
Extremely simple to remove.
Okay, I like that because some people have been doing some tests and they said, well, I seem to get water spotting. I don't, because I have a water softener system at home and my water is already super clean to start off with. Some people even use deionizers, so that's not an issue. But for a lot of people with hard water issues or who sometimes even have sprinkler systems that sprinkle water onto their cars and they weren't there to address the issue immediately, and that bakes into the hot sun. So you can still see traces of that, but they're much easier easier to remove if your vehicle is protected with that graphene coating. Does that make any sense?
Extremely simple to remove, and it goes back to how hard is their water. And there's some areas of the U.S. that they have really hard water.
Yeah. So it doesn't prevent 100% of the water spotting. That's not what you guys claim either, right? What we're talking about is reducing the chances and making them easier to remove. Does that make sense?
Mm-hmm. Yep.
Okay.
Yeah, that's a good way to put it.
So let me move on to probably a sick question. I don't know if you're going to laugh anymore after this one, but so viewers say that they heard that graphene coatings are snake oil. There's these conspiracy theorists out there that think that it's snake oil, just like ceramic coatings were a thing 5 to 6 years ago. So that they really are just graphene coatings are really just ceramic coatings, just infused with a bit of graphite powder to darken the color, and that it doesn't actually bring any benefits to the products. Now, is that true? Is our graphene just pure marketing? You sprinkled a bit of fairy dust into the product itself, call it a day, and sell it?
Well,
don't lie.
That would be magic if it was, and
yeah.
Chemists are close to wizards, so but but no. Well, so truthfully, I can't answer to what competitors are doing.
Yeah.
So we can't test every single competitor out there, and there's too many that are trying to come out with one. But with our product, every claim that our company makes, we stand by it. And so we don't package snake oil, for example.
Yeah.
So this particular item, I formulated this product, and I formulated it with the maximum amount of graphene oxide I was able to get into solution. And so we went through a lot of formulations, a lot of derivations of various, actually a lot of trial and error, to put it that way. And it wasn't until all of our testers, both internal and external, they finally approved of it. That's when we were able to move forward with the product. And so I don't even remember which formula version that we were on, but it took a long time to finally get to where we were. And so again, I can't say what the competition's doing or what other market, but I can't speak to ours, and we stand behind every single claim that we make.
So it's not just added powder or graphite powder into a product to make it darker just for appearance. So there is functionality behind that.
Yeah, in addition to that, the formulation itself is quite complicated. There's catalysts in there. We have various types of distillates that are in there. One is a slow cure, one is a fast cure. Everything has to do with all of them play a synergistic role to the other.
Yeah.
And so every component that we chose, we were very specific in choosing that one. We made sure, like, if we want to make a claim, will this component satisfy that claim?
Yeah.
And so we made sure to formulate to those claims, and then once we finally got the claims, what we ended up finding was additional synergies, which is like the water spotting. Originally, we didn't know we were going to achieve that, and then when we found that it reduced the water spotting, it was like, wow, let's keep going.
So, okay, now that you're on water spotting, that leads me to my next question then. A question that often comes up from viewers is graphene coatings are supposed to lower the chances of getting water spots by lowering the surface temperature or dissipating heat better. Is this true? What's the thing behind it? Because we have seen, again, some tests where some people were applying it to a hood or a surface on the vehicle and then taking temperature readings, and it didn't seem to have any effect. Was the test flawed in a sense? How do you guys test for that? So what's the whole thing about water spotting reduction through lowering the surface temperature? Because that's a big claim from graphene coatings.
Well, I guess what we've seen is the lowering of the surface temperature. That's an overall attribute behind the graphene oxide that was that we had discovered. And so this is actually done by thermodynamics. And so if you go back to your chemistry and biochemistry days and you whip out thermodynamics, and you're going to be talking about heat transfer. And so with this heat transfer, it's always going to go, heat always goes from hot to cold.
Yeah.
Which is why when you see the NFL athletes in the dead of winter and they remove their helmets, especially in the Chicago area, and then you see all the smoke just coming off their head, because it always heat always goes from hot to cold. And so what we have seen with our product is whenever it's sprayed onto a surface, and this should apply to most graphene products, regardless of company, but specifically with ours, when it's applied to the surface, the heat is transferred from whatever the clear coat or the windshield or the wheels. You name the hard surface. Whenever it's transferred from a non-porous surface, the heat goes from the non-porous to the liquid. And that's when you start to see the difference in color because the liquid will go on black and then it turns clear. So as the liquid is absorbing the heat from the surface, it's starting to orientate itself because of the hydrogen bonding. And then that's when it starts to dry to that whitish type color. And so with our product, unfortunately, you can't see it with a thermal gun because I've heard of people trying to do it.
Yeah.
And I've explained it to our brand managers. It's like, well, the thermal gun isn't going to read it because as you're shooting the surface, the heat is going from the surface to the coating, and the coating is on top of the surface. So now you're measuring the heat of the coating, and so the only way to do that would be to strip the coating, of which I have to say, good luck trying to do that because unless you really buff it and buff it out, then you're really not going to get it out. I mean, it's chemically resistant. So then the heat guns, that's what they're measuring. And unfortunately, I wish it was more visible on the videos because then it would be really cool to see that. But it's not always feasible. Well,
at least that explains it. So thank you, because a lot of people go only by what they see. So obviously using those infrared guns, when you're aiming at a surface and getting that reading and you're comparing it to the product that you applied next to that graphene coating, and you're getting essentially the same number. And so you're assuming that there's no heat dissipation. But what you're saying is that no, actually you're taking the surface temperature of the coating that's applied on top, and not exactly what it's doing underneath to reduce that surface temperature.
I mean, because really the only way to get a differential surface temperature would be to apply it. You would have to apply the product really cold, and then that's when you would see the temperature drop, and that's because of the cold liquid. But that's more of a false type of test. I mean, that's really not a true test like real life. And so with our product, that's what we have seen through, whether it be in direct sunlight in my driveway, through various partners that we have that test the item, or here inside Gold Eagle in our garage. Whenever we've done it and we've done it under heat lamps, it's just you don't really see the difference with the gun. The difference that you see is when the product starts to turn clear, and it's not because the solvent is flashing up. That's because of the orientation of the product and the catalyst that's in there that's speeding up the process.
Okay, so let me ask you a question then. If you guys are making the claim that it's lowering surface temperature, how do you guys test for that? How do you know that it's actually lowering the surface temperature?
Well, because whenever you have lower surface temperature, that's when you start to get the reduce in the water spotting. And so internally, whenever we do this testing to justify whether something is a claim or not, what we're looking at is, so in this case here, what we're looking for is how the coating is working on the surface. So for this specific item, we're not looking at it from a thermal imaging standpoint. We're looking at it from, if we applied this to a hot surface, and that hot surface is it's not quickly baking the product, because that's essentially what heat transfer would do. If it's actually still absorbing the heat because it's slowing down that reaction, the gun itself, it won't register the difference. I hope I'm answering the question, but and if not, then please repeat it. But yeah, anytime we're doing the internal testing, we're trying to look for variations and any kind of heat signatures. And so with this one, I mean, like I said, unless we're pouring ice water onto the surface, you're really not going to notice a big difference, because we're talking like tenths of a degree versus 1, 2, 3, 4, 5 whole numbers of a degree. And so yeah, hopefully that sort of answers your question.
Maybe let me twist this from another perspective then. If your boss comes in, so from 303, has no chemistry background, and he's in a rush and just asks you, David, how is that surface temperature lowered? Explain this to me in one phrase.
Thermodynamics.
Thermodynamics. So you do have a scientific way to
Yeah.
understand or know that you're actually are reducing the surface temperature. So this is not
And
just a bold
this
claim.
is,
There's
yeah,
actual
so far,
physics behind it.
yeah, this is the only product that we have that lowers the surface temperature. And so all of it has to do with going back to the three laws of thermodynamics. And so this is the only one so far that's been able to achieve that. We've tried to do that with other products in the past. It never worked because we were never able to create the same type of coating in the past. But with this one, for whatever reason, it was achieved, and all of it has to go back to is with physics. So whenever I speak to my other chemist that works in the lab with me, and his background is in thermodynamics, and so whenever I'm talking to him, and I'm like, well, can you just explain to me like this, like I'm 5, like what is going on?
Yeah.
And then he's like, well, when you consider heat transfer, he's like, where does heat go? And it's like, well, it's going to go from the hot to the cold. In this case here, the liquid is colder than the surface when you apply it. So the surface is going to transfer the heat to that liquid. And then the heat is not going to completely dissipate into the environment, because at that point you have an equilibrium between the coating and the surface.
Yeah.
So you have this equilibrium that keeps going on, and it just that balance is really what is registered. Well, in this case, I guess not registering on the thermal guns.
And if you can explain it maybe for the viewers out there. So if they're trying to associate, okay, lowering the surface temperature, how does that lead to less water spotting? Is it because of less evaporation and less minerals left behind on the surface to etch through the clear coat and leave that mineral deposit?
Yeah, so whenever you lower the temperature and the coating at this point is what is in contact with the water, that coating is going to take some of the heat from the coating itself, and it's going to transfer it to the water, and it's going to speed up that evaporation. And then whenever it does that, because of the coating having all of the hydrophobicity, and there's a few other factors in there too, but that coating is no longer going to allow the calcium deposits to adhere, because it's literally going to evacuate them off the surface. And
Okay.
so that's where all that comes in.
Let me, good, I love these answers. Let me take a small comical break. I see you're not sweating, so that's good. I hope I'm not too harsh with the questions. You've been great so far. I mean, honestly, you haven't backed out from any question, and you're just answering them. And a lot of people I know sometimes with chemistry backgrounds are camera shy, but that doesn't seem to be the case with you. So you're doing quite well. Maybe you'll start your own YouTube channel one day, who knows? So that's good. Yeah, you're doing extremely well. So if I know it can be nerve-wracking sometimes for people to be on camera. Not everybody can do this, but you're doing super well. So hopefully my viewers are appreciating that you're taking time out of the day for this.
Well, I do feel the difference. If you had a thermal gun,
so we have to go through with your graphene coating then. So let me move on to the next question. People think that for graphene coatings or for any coatings like ceramic coatings to be effective, they have to be able to harden on towels. So once you're done using them, the towel has to be crisp and hard. But 303 has said that if you clean the applicators after use and the microfiber towels after use, we can reuse them. So does that mean that your graphene coating isn't as durable? Are we supposed to have it harden? Like what's the whole hardening thing?
Well, the hardening aspect of like let's say a traditional ceramic coating is actually the components within the coating itself. So our product, although it works well on non-porous surfaces, well, we haven't seen that same benefit on a fibrous surface or a porous surface, which is why it can be washed out of the microfibers. There's minimal transfer from the coating once you're polishing it off the surface onto the microfiber. It's pretty minimal, and the reason why there's a little bit on the microfiber, and it has to do with, I mean, I really tried to overload the product with as much graphene oxide as possible, so you will see some occur on a microfiber, but because it doesn't bond very well to fibers, at least in a liquid phase, it doesn't bond very well. Then that's why it can be rinsed out. but
I love these explanations.
it doesn't reduce
See,
the
there's
performance.
always a scientific answer to everything, so I like that. Okay, so then if they do wash the applicators and towels immediately after use, then they can reuse them without any not being scared of scratching the surface if they reuse those towels, right?
Yeah, they're perfectly fine to be used.
Beautiful. Next, what are, according to you, the main differences between graphene coatings and ceramic coatings? That's probably one of the questions that people ask the most. So to summarize it, is it only the chemistry? Is it the same chemistry background? Obviously, it doesn't seem like it because we saw the chemical backbone. But what are the main differences that you would say between traditional ceramic coatings and graphene-based coatings or graphene oxide-based coatings?
Well, traditional ceramic coatings and the graphene coatings, they're going to be very similar still. The base formulations are very close. Because you're still looking at durability, you're still looking at like a hardening on the surface. So there's a lot of aspects that you're still looking for, and in order to achieve that, there's only a few chemicals that actually do that. So then the major difference is just the introduction of the graphene oxide or the graphene if someone is able to use pure graphene. But the graphene oxide is the major difference between the two. So you're still going to have the same basic components. You just have this additional feature that's on top of those. And so they're very similar still.
And would you say, because I remember when we used to explain ceramic coatings, basically, so people can visualize it on a paint surface, so that has hills and valleys, because obviously clear coat is not flat if you look at it at a microscopic level. What coatings do, ceramic coatings, they're kind of a resin that comes and fills that in and has SiO2 particles or TiO2, depending on what type of ceramic coating it is. But basically there's particles in there that have high water contact angles and help to repel water off and many different chemical properties. So is it roughly the same thing with graphene oxide? Is it kind of a resin-based carrier that goes on like a jello to fill in those hills and valleys and then has those molecules in there that have those chemical properties to repel water and to protect against UV rays and all that kind of stuff?
Yeah, actually it is still resin-based. So the resin is still in there, and that's for the hand-applied ones.
Yeah.
So for all the hand-applied, and so this I guess would be specific for hand-applied products. So the hand-applied still have the same resin base, and then that resin, as you said, it fills in the voids, or so it reduces the hills and the valleys, which makes the to the eye it makes it look like it's flat.
Yeah.
And so then, but the graphene itself, what that does is that ends up creating sort of, if you want to think of like a chainmail. So if you think of like the knights of old when they used to wear the chainmail so they wouldn't get by swords, that's literally what the graphene oxide is doing. So you have this hydrogen bonding that's stacking one on top of the other, and then they're also coming in on the sides next to each other. So it's no longer visible, but now you have this like coat all across your surface, and so that's where the graphene oxide or the graphene coatings are differ from the ceramic coatings, because ceramic coatings, they don't have that type of structure that's in addition to.
Yeah.
And so and then in a sprayable form, like what we're doing, it actually allows for easier dispersion of that graphene oxide across the surface. And then the beautiful thing about whenever you're applying our product, you don't have to worry about going back and doing all the additional corrections should you mess up with a like traditional ceramic coating. Those imperfections aren't going to occur. I mean, literally all you have to do is wipe it into the surface and just work it in, and it's a real easy work in. It's not like you're going to be sweating and doing anything like that. So the product, so the graphene versus ceramic coatings, they're still similar, but hopefully I'm answered the question.
Yeah, well, this leads, it always leads to more questions. So it's interesting to see because the product, it is like you touched on simplicity of use. And that's one thing I noticed. The application was like, man, we've come a long way to make coatings easy to apply. And so why did you choose to go maybe with a spray form? You claim up to a year of protection if people apply it correctly. And of course, depending always on conditions, like for any coating. But there are some that are in a bottle, in a glass bottle, like ceramic coatings that claim 3, 4, 5, 7 years of durability for graphene. So why did you go in a spray form? Was it only for the ease of use? Why didn't you go for like a multiple year glass bottle type?
Well, just what you said. So we were looking at how can we give the consumers the best experience possible. We could have easily done the small little 1/2 ounce, 2 ounce bottles and seen what happens, but that would make it the same old, and for the novice consumer, that's going to be pretty tough to use because most people don't know how to prep the surface properly.
Yeah. And
so we decided to go with the spray route because of the ease of use. And then as we were formulating the product and as I was looking at the various types of distillates to use in there, that's when I discovered, I was like, okay, not only is this easy to use in a spray form, but if you mess up or if you overspray somewhere, all you got to do is just wipe it off. I mean, or actually, well, it won't truly wipe off, but it'll wipe clear.
Yeah.
And it's not going to change the color of the surface. So, which is why you can use it on windshields, and you can use it on like the black trim that goes around the windshields.
Pretty much all the exterior surfaces except rubber, I think.
Pretty much everything, and then rubber being a porous surface, unfortunately, it doesn't give you that same vibrance as what it does on a non-porous. But because of the clarity behind the product, that's the whole reason why the product can be used very, very easily. It can be used by novices. So, you know, if you guys are out there and you're just starting to use a product, this one is actually a really good one to start with, because the chances of you messing up your nice vehicle, and I don't know anybody who doesn't want to take care of their cars, but the chances of you messing up that car are very slim.
So 303, I guess, based this more towards weekend warriors, enthusiasts who want ease of application and who don't want to worry about all the paint prep stages. Because obviously, this is a detailing channel. I always recommend that people go through the full prep stage. So the pre-wash, the wash, chemical decontamination with iron removers, mechanical decontamination with clay bars, and then machine polish the surface, use an IPA, and then apply your protection. But in this case, you don't even have to go through all that. And I showed that in the video. I mean, you pretty much wash your car, you dry it up, and then you can start using the product immediately, right? So did you guys have that in mind for, like you said, the novice who wants to dig in or dive into the graphene coating world and have something that's durable more than the typical carnauba wax, which only lasts 3 months? So you get a product that lasts up to a year, and the ease of use was the main thing. So remove all the flashing worryings and all the curing times, and because there's not even a curing time on your coating.
No, it's literally instantaneous, and it goes back to the whole thermodynamics explanation. So when we were doing this, and we're thinking, okay, well, how can you get professional grade products on the consumer level? And that's why we wanted to mesh the two together. So we maximized the amount of graphene oxide that can be put in there. And there's actually the catalyst is at the maximum level as well. If we went any higher, then you'd pick up the bottle and it would just be a solid chunk of, not even a liquid anymore, just be solid and you never get it out. And so we try to put everything to the max. That way the product is always going to adhere to every single claim that's put on there. And then we're trying to give the consumers the best possible use of the product that they could achieve.
So now that I have the guy that worked on the product with me, one thing that I found was amazing again for the person out there who doesn't have a lot of time or energy or maybe knowledge to fully prep their paint, is that if they have a coat of wax or a traditional paint sealant, normally we say do not apply ceramic coatings on top of those because they won't bond properly. They'll be rejected by the coat underneath. So you have to apply them to virgin clear coat. In the case of your graphene nano spray coating, you claim that you can apply this even if your surface is already waxed or sealed with a traditional paint sealant. So why is that? Why is it compatible, whether it's virgin clear coat or there's already protection on there? No worries, just use it and apply it.
Well, it goes back to the structure. So that structure, it starts to interlink. And I mean, obviously with coatings, the best thing to do is always to prep it.
Yeah.
And to do everything that you have videos for. And so that's the best course of action to get the maximum effectiveness. But if you choose not to go that course of action, we recommend minimum washing the car.
Yeah. And
then once the car has been cleaned, then apply our product to a dry surface. And so this structure, when it starts to interlink, the substructure or the subsurface, although it is important to have that be as pristine as possible, it's not required because it's going to start to interlink together, and then it's going to create that chain across the car. So you're going to have this imaginary barrier of protection, or I should say invisible barrier of protection, and it's all because of the way the product orientates to itself. And we haven't seen very many that do this. It's actually been something that's been very hard in the lab to create. And so whenever we've stumbled upon these attributes and the way that it behaves, it was really cool. And then that's when we thought, I bet you users would love this too.
Yeah.
And regardless of your level of experience, we have you guys in mind. We're trying to think, professional for whomever.
So that year of durability that you'd get if you apply it on a virgin, well-prepped surface, if you apply the product on top of existing waxes or sealants, do you still get up to that year of protection, or is the durability obviously compromised because there's something underneath?
Well, it has to do with the subsurface, but what we have seen doing some real-world testing, as well as some accelerated oven testing, and so what we have seen is the subsurface. The product does last at least a year. It'll last longer should the subsurface be better, but just like other products, if for some reason that subsurface starts to degrade or start to break down, let's say there's no UV inhibitor inside of whatever wax that was put underneath the graphene product, and that now the just UV degradation or weathering is starting to break down that subsurface. Well, then the graphene product, although it is interlinked, it's not going to be able to withstand Mother Nature. Okay. So the product will last at least 1 year, and that's all based on internal testing that we've done.
Okay, so since you're talking about internal testing, how do you get, because this is another question that a lot of people say. So the claim is up to 1 year of protection. How do you guys test for that? I've heard that you said it can resist up to 30 washes that you guys have done as well. So what are the tests that a company like you and chemists like yourself do to come up with a claim that says it lasts a year, it lasts 3 years, or whatever amount of time? How do you come up with that?
Well, so our internal testing is a variety of things. Behind me, you see some instruments. They actually help with that process. But more importantly, what we do is we do some accelerated testing. So we'll do a freezer and we'll do an oven. And so we'll take a test panel, and it's not going to be like a panel off a car. We're talking little 5x9 panels. And we will coat those panels. Some of them will scratch them. Others will leave them as they came. And then there's other panels that will be washed. And then we'll dry and we'll do the process as per the directions. And then we'll take those and we'll put those in the oven, and then we'll take those out once a week, and then we'll spray those down with a soap water combination. And then and if water is still beating and sheeting, then we know that we're good. But if water were to fail, if the surface were to fail and then you start to get puddling, then you know that the coating is no longer there. And so we'll do that both in the oven and in the freezer. First, we'll let them go to room temperature before we start to manipulate them. And then as far as the washings are concerned, in our Gold Eagle garage, just a few years ago, we were blessed by ownership to say, yes, build a garage, build a trough. I mean, you guys do what you guys need to do in order to test the products internally. And so we went in the garage, and that's where we coated it was, I believe, the bumper of a truck. And then at that point, we did one side with coating, the other side just virgin natural. And then we washed them. First was 28 times just to see whether or not it would fail, because most of the competitors did fail, like around 11 times and others around 20 times. And then finally at 28 times, we were like, okay, well, this is already 1 year of durability. Let's just keep going. And so
you based the year of durability on the number of washes. So what is it, like 2 average washes per month times 12 months? You're already past 24 months. Is that
exactly? Because yeah, most people, most consumers, from what we've seen in market research, they tend to wash their vehicle maybe once every couple of weeks. Okay. So whenever you take the 52 divided by 2, then that's when you come out the 28, and then that's when that's how we came out with our testing for a minimal of 1 year. Yeah. And then and from there we just kept going, and then finally we just stopped counting because we're like, this really isn't going to come off unless we start to physically mechanically abrade it.
Abrade it, yeah. Okay, cool. That's good to know. So basically, you base yourself on scientific data, and that's how you can do those accelerated tests that kind of let you guesstimate based on actual facts and numbers on what the durability can actually be in the real world.
Yeah, and in the end, it all boils down back to surface preparation. So,
of course,
the better the surface prep, the better you're going to be. If you do nothing to prep that surface, well, then you pretty much you get what you prepare for.
Absolutely. My next one. So are graphene coatings as chemically resistant compared to ceramic coatings? So we know that ceramic coating torture tests are a dime a dozen on YouTube, and they can resist an onslaught and a barrage of chemicals like degreasers, APCs, multiple washes, iron removers, bug removers, blah, blah, blah. Are graphene coatings as chemically resistant in your opinion and your testing?
Yeah, they are based on our product. They are. I mean, it's hard to say what the competition on how they formulate theirs or what concentration levels that they're using. But from what we've seen, yeah, they are chemically resistant, and they do stand the test of time.
Test of time. All right, that's good. What can I say? The one do I have? First of all, I got to make sure. Is there anybody else in the room with you right now? Are you alone?
It's just me.
So there's nobody from the marketing department there? Okay, let me try and get something.
No, because if they were, I'm pretty sure they'd tell me to be quiet a long time ago.
I love that.
They'd say, stop giving away the secrets.
The one question that comes up a lot is, if we're talking about graphene oxide and not pure graphene, why do the bottles themselves, and this is not just 303, it's all the companies, why is it called a graphene coating? Is it just purely a marketing ploy, a marketing scheme? Is it to not confuse people by saying, well, this is a graphene oxide based protectant, and then people get confused with chemistry? And so why is it called a graphene coating if it's a graphene oxide based coating?
Well, because you still have that graphene base structure. So when you look at whenever you look at this, and you're going to see the base structure is still the same.
Yeah.
So regardless of which one you're referring to, that's where chemically we could still call it graphene. So it becomes more of a question of semantics, because the carboxylic acid group does make somewhat of a difference, because that incorporates hydrogen bonding, which is actually a better thing to add to it. But the base is still the same. Okay,
so it is technically correct to still call them graphene coatings, although they're graphene oxide based.
Yeah,
it's not just this marketing thing that lets confuse people and make them believe that it's pure graphene.
And it's hard to say what the competitors are doing, because but as far as Gold Eagle is concerned, whenever if we say there's graphene in there, it's because we know that there is graphene in there.
For legal reasons, obviously, too. You guys wouldn't want to lie.
No, we our ownership really frowns on that. They allow us to, and even when it comes to exaggerating claims, they won't allow us. And what they'll say is to the marketing team, if David and Drake and Mike, if they do not approve of what you guys want to claim, you cannot claim it. And we internally, we'll do a whole bunch of tests, just a litany of them, because we don't want to be called out, and we don't want to have to defend ourselves. We would rather say, is it in there? Yes, it is. Or, does it last a year? Yes, it does, and this is why. And does it lower surface temperature? Yes, it does, and this is why. And so we will make sure if it's a claim, we will back it up.
And I appreciate that. And I mean, I've dealt with 303 products for a long while now. And that's one thing I normally see, is that when you guys do claims, like the touchless sealant, which was a great product, SiO2 based, and you talk about durability, you guys are pretty much usually always spot on. And it just shows the transparency of the company. So kudos to you guys. I love honest companies out there.
Integrity is a huge part, and it's one
absolutely.
Of values.
Reputations are hard to build and so easy to destroy.
Exactly.
I see that. Well, the next question that I do have for you, I think we kind of answered this because I can see you now. So I'm talking to the chemist and I see you're in a lab. But a question that viewers had is, does 303 blend its own graphene coating, or do they source it from a third-party blender? And what separates your graphene offering from others on the market?
Yeah, so with us, we don't produce the raw material itself because of, well, that's actually done at a chemical company much larger than ourselves. But we do formulate, blend, package, and ship from our facility.
In the USA.
Done in-house. And so we'll do that as often as we can. Granted, if the situation arises where we're over capacity, then we have no choice but to have someone else fill it for us. But in that event, the product will come from our facility as a finished good. The formulation is always our own.
So you R&D and develop it in your lab?
Everything is done right here on site.
Okay, wow, that's very good, because I know a lot of major brands, they do not blend their own products and they go through third-party blenders, which is okay too for me. I mean, bottom line is the performance is important. So I know some people freak out like, oh, they don't even blend their own products. I don't care as long as the product performs well. But it's nice when companies like you guys can do the development and come up with products on your own. You guys have your own chemists, you have your own labs, so that's kind of cool as well.
Yeah, being the R&D lab manager here. That is one of the added benefits that we have that some companies don't have is our own research facility. So what I'm in this area that you see it's actually called the Innovation Center, and we are completely separated from everyone else within the company. They are literally half a mile away from us, and so if they want to come visit us, there's usually a purpose behind it because no one ever wants to walk back here. So we have our own entrances and exits, and it's because ownership decided, they're just like, okay, well, if we're going to have R&D truly do R&D, then they need to have their own location. Yep. Where they're not going to be bothered with casual conversations of people just saying, hey, how's it going, or talking about the weather. Instead, we're actually in here playing with all of our chemicals, and I'd move the camera around, but then you'd probably end up losing me. But but behind me, I have a counter full of chemicals, and it all has to do with, okay, well, how can we try to incorporate and let those people, or actually what the CEO told us was, let the chemist dream. And that's how all these products start. Is it all starts with a dream or an idea, and then we're just kind of scratch our heads as to, well, what can we do? Does that even make sense? Like in the realm of physics, is it even possible? And then after we answer those questions, that's when we start to ask around, and then we formulate it internally, and everything is done in-house, which is a huge advantage for us.
Yes. I love that management understands that you have to let a creator create, and there is a thought process behind all this stuff. So you can say that you have creative freedom to do your work?
Oh, yes.
Oh, that's cool. And I can
Definitely,
see you smile, so it must be cool to work there. Yeah, it's always nice, because sometimes what I've seen with some brands is that they have so much pressure from management to just crank out this product, and they don't care what it takes, just do it. And there's no much freedom left to the chemistry team. And I find that scientists, man, you need to let them go, let them fly, and let them come up with crazy ideas. And you never know where that can lead, or to which product development that can lead to.
Yeah, I mean, we do think differently than the average person, I guess you could say. It does take a certain type of background to do formulation, and ownership. They recognize that, and they fully embrace it, because whenever we go up front, they're like, okay, well, if we ask you a question, are you going to give us the technical response that's just going to fly over our head, or are you going to try to make us understand? And our goal is always to try to make people understand. Unfortunately, it's not so easy sometimes. But yeah, I'm very grateful. The ownership is very, very understanding of what we do, and they just love it, because when they come back here, it's always one of the moments when I see them smile the most, because they're like, well, what crazy thing are you guys coming up with now?
I love that.
Like, well, we really don't want to tell you, and because if we did, then then cat's out of the bag. But
well, you know what? Tell your bosses that this is Pan approved. Anybody that lets their employees have creative freedom. I love it. We're almost towards the end now with the questions. There is, I think, a few more. So let's move on. Is graphene here to stay? So this is what people are asking. Are we going to continue to see an evolution in this technology as we did with ceramic coatings, or is just us a one and done project, and then 6 months from now, nobody's going to be talking about graphene anymore?
No, we definitely believe this is here to stay. This is one of those items that is going to be very important to the automotive detailing world. And the technology that surrounds it, what you're looking at is just the beginning. It's only going to get better, and it's going to become more robust.
Good. And would you say there are any negatives to graphene coatings currently? For example, we know that ceramic coatings were more prone to water spotting issues. Are there any issues that you're aware of with graphene that you would want to see improved, or what the future is?
So first I'll answer the first part. Are there any negatives? Not that we've really seen. Our testers they were pretty rough on me with their criticisms as to what they liked and what they didn't like. When it comes to any negatives, I really don't foresee any negatives because there have of testing, but again, that applies to our product internally.
Yeah.
Comes to others, it's hard to say whether or not they're having problems with theirs, but the jury's still out there. So I guess to answer the second part of the jury's still out there for the graphene items, whether or not if the market mandates that there be more created. But as far as Gold Eagle is concerned, we will be coming out with more. Just don't tell that to my marketing team just yet.
Oh. So maybe a scoop for the Pan TheOrganizer viewers. I love that. Graphene technology, there's obviously, I deal with so many different brands, and I get sent products like there's no tomorrow. 80% of it is garbage and gets thrown away. So many of my viewers don't know that. Only roughly 20 to 25% actually makes it to my videos, because I only review products that I actually love and brands that I believe in. And so I've seen some companies claim that, okay, it's stronger than steel, it's as strong as Kevlar and blah, blah, blah. Yeah, that's pure graphene if you get it to that 2D layer atom level. But for graphene oxide right now, I think one question that pops up from viewers is, if it's so resistant, why doesn't it last forever on a vehicle surface? If you can briefly answer that.
Mother Nature.
Okay.
We've never been able to defeat her. Mother Nature comes within a variety of forms: snow, sleet, hail, heat, dry heat, humid heat. You name it.
Tree sap, bird droppings.
Yeah, we can't. There is no winning against Mother Nature. Will always win.
So you're basically trying to do the best you can, knowing that those factors come into play. But okay, so that's the reason you'd say. Are they is the graphene coating, or at least yours, is it toxic to use? So are there any precautions, any masks we need to wear, ventilated spaces? What's your take on this?
Well, since it is being used in a professional setting, more than likely it's being done outside. But we always recommend doing it in a well ventilated area, and I believe on the back of the bottle it's part of the warnings is a well ventilated area. And so with our product, the toxicity is more so there's always an aspiration issue. Anytime you're talking distillates, whether it be our product or anybody's product, distillates always have an aspiration. So distillates tend to displace oxygen. And if you can't breathe, then the bad things happen. But with our product, what we try to do is we try to limit the amount of atomization of the liquid, and so that way
So basically, that's the amount of droplets that are airborne, right?
Correct. Yeah. We really try to limit the amount of airborne particulates. So then our product, is it toxic? The answer is, we would have to do a lot of testing to truly find out, but based on what we know now, the product is more of an aspiration, and we warn people on the bottle to just try to do it in a well ventilated area. Pretty much it's like, just take care of yourself.
Yeah.
Because the product itself, it's not acid, it's not base, so it's not going to burn your skin.
Yeah.
And it's not going to melt it off. And so just safety first.
So if you're working outside, no real issues. And if you're inside, well-ventilated space, and like I always do in my videos, always wear gloves, right? You don't want chemicals touching your skin.
It's the best thing to do is always try to think safety. And so gloves, glasses, if you have them, I highly recommend the use of glasses, because whether it be solvent-based or even water-based, I mean, if you get a bottle of water and you throw that in your face and the water gets into your eye, it's going to burn.
Yep.
And so it doesn't really matter what the liquid happens to be. Always try to think, err on the side of caution, and, you know, put on your gloves, put on your glasses, what we call PPE, so the protective, personal protective equipment.
Yeah.
And try to, and if you're going to do it in a garage, leave your garage door open, or have some sort of way of having negative pressure, so that way it blows out.
Perfect. For ceramic coatings, typically they need a maintenance topper every 2 to 3 months to either replenish the resin or boost the properties to maintain durability and the properties of the coatings. Is it the same with your graphene coating? Does it need maintenance? If yes, what does it need? Does it need any toppers? What's your take on your version?
Well, in general, I would suggest to reapply every 6 months. It's not needed, but I would suggest that, and if anything, it should become part of just your maintenance program.
Yeah.
You know, when you go to change your oil or rotate your tires, just like, hey, maybe I should just apply this to the car, just because I'm trying to show it some love. Yeah. And you know, and just follow the directions in the bottle.
I know a lot of people don't read the instructions, and that's why I try to be very thorough in my tutorials to show them the proper steps. Even after 23 years of detailing for myself, I still follow the instructions to a T. This is maybe my science background. When you have a lab protocol to follow, you follow every step, and it's very important to be very precise. So I always recommend that people read the labels. Each product is different. And I mean, you guys, the chemists, have gone through lengths to test these and to make sure you come up with an application protocol, so people have to follow those, right?
Yeah, exactly. You know, follow your directions. Just like you said, most people don't read them. And it's ironic how many phone calls I get saying, I applied, you know, previous products. I've applied your product and it's not working. And it's like, well, what did you do? And then they say, well, I just sprayed it. And it's like, hello, like, did you do anything else? And a lot of times they don't. And it's just, you know, please be sure, read the directions, read the warnings, follow directions. But I do recommend just reapplication once every 6 months or so, or just anytime you do your maintenance program. And it's just super
quick to apply. I mean, spray on, wipe off.
You know, and then when you consider like the price of a car and the age of a car, you know, if you really want these things to last, and so just show some love, show some care to your vehicle, and just take care of it. You know, I don't know about you, but I love getting my back massaged, and I'm pretty sure a car, if it could speak, it would love to get to be polished and buffed and taken care of.
Absolutely. Well, if people are watching my channel, obviously they love their vehicles, so this will be a no-brainer for them. We're talking about vehicles, but another question that came up from people who love boating: can your product be used on fiberglass, gel coat, basically marine application?
From what we've seen, the short answer is yes, but we still have to do some more testing on that. So we haven't seen any negative aspects of application. But we do need to do some more testing just to be 100% verified. I know we're starting to do that now. So it's hard to say as to when those answers will come. But based on what we know about the structures of clear coats, based on what we know structures of the isinglass or any type of the polyacrylic windows that the boats have, the product is compatible with those surfaces. Okay,
good. So before last question, there's 2 questions left. Are you still hanging in there? You were pretty good. I think this was a cool one. So they say that some chemists does the fact that most companies that have experience with ceramic coatings, does that help them create graphene-based coatings? So basically the fact that you have experience with SiO2 through your products, was that of any help for graphene coating production?
Not really, no.
No? So you start from scratch, completely different formulations?
Yeah, you start from scratch because whenever you're researching compatibilities, even though, so for example, let's say, because well, as you know from your chemistry days, likes dissolves likes. And so whenever you're looking at the various types of solvents, you're looking at the various types of catalysts, and then you have to look at, okay, well, what is the structure of this? Is it even compatible? Sometimes you get things that are temporarily compatible, or what's known as miscible, and then they crash out of solution. And so having the ceramic background, it's a nice to have, but it doesn't necessarily mean that you're going to wind up with an excellent graphene item, because you do have to figure out, okay, if it worked for ceramic coatings, and usually that's like a polysilazane or something, some sort of material like that, is it going to work for the graphenes? And the answer is not necessarily. Sometimes you do have to go back to the drawing board, and then that's when you're looking at, okay, well, what are the various aspects that we're trying to achieve? And so there is a lot of boxes that need to be checked during the formulation process.
Maybe because I know some people also that watch the video sometimes have a bit of a biochemistry or chemistry background. So if we want to geek out on the structure, because you showed the structure, and the way those molecules, they bond together, is it through the hydroxide groups, or what we call alcohol groups, the OH basically? Is there a bridge formed between the hydrogen atoms in between themselves to help them link and mesh together? Is that how you would describe it?
So we'll hold this up again.
Yeah.
So then anytime you're starting to get these, the hydrogen bonding, so those hydroxyl groups.
There you go.
And then you also have that double bond oxygen, which it's not shown very well in this picture, but it's a carboxylic acid group. So you have carbon, and then you have a double bond that comes off one way, and then which is your oxygen, and then down this way you have your hydroxyl group with your OH. And so the hydrogen bonding, it does help for the bonding of the actually it helps with the stacking. It promotes the stacking. And so whenever they start going side by side, you also have those sticking on the ends. Yep. And so then you have these various types of let's see, the carbons itself. You start to get some pi binding, some pi interaction, and then you start to get the hydrogen bonding interaction, which forces the orientation. Yep. So yeah, I know that was long-winded, but I hope that helped.
We like geeking out. So the final question of the day, and maybe the most dramatic. We're not going to name companies because that's not the point of the video, but some viewers have highlighted the fact that it seems that some chemists from other car detailing brands are saying there isn't a performance change between traditional ceramic coatings and graphene-based coatings. Is it because they haven't cracked the graphene code yet? Are they just frustrated that they haven't been able to come up with something? What's your take on this? Some that seem to disclaim graphene coatings that, oh, it's impossible. Nobody can do this. It doesn't exist. It's all fairy dust and gold powder. So what's your take on this?
Well, I find the question funny, but what I would say is it really depends on the formulator. Because what we have seen is it can be done, but the question is, do they have the proper tools? Do they have the proper executive team that's saying go out there and dream it, or are they being too pressured to come out with something? And so in our aspect, I mean, we've got the best of all the worlds. We have time, we have patience, and then we have our purchasing team. They do a great job communicating with all of our suppliers to figure out who can we work with the best in order to get this material the quickest. And so really it's all based on how what type of time frame the formulator has. So is it possible? The answer is yes. Is it something that is difficult to do? Oh, big time. And and is this something that's fun to do? I mean, extremely. Figuring out how to do something new is actually,
I love that.
It's like being in a playground. Yeah. So you have all these chemicals, and you're basically the kid in a sandbox. You're going, well, what can I make today? And so, yeah, it's when it comes to this product, it all depends on the formulator. It depends what types of claims they're trying to hit, what mode of application they're trying to use, and so all of that will dictate whether or not something can be created. And then all that will also dictate whether or not something is even durable.
Yeah. And I'm sure the industry will find a way to eventually make it that pure graphene. Maybe we'll be able to be laid on to exterior surfaces. I'm looking forward to the future. Well, when you're not creating, you're obviously, I think you're a family guy.
Correct.
So I've been told that you have a son named Ashton. Is that true?
Yeah, that's true. He's 10 years old. He's an
Apparently, he's a big fan of the Pan TheOrganizer videos, and he does some videos on his own. He has a YouTube channel.
Correct.
So I always like to give shout outs when I talk to good people and what's his YouTube channel name?
His YouTube channel is Super Canine Let's Play.
Super Canine Let's Play. And what does he do? What general videos does he do?
So he's been doing like cartoon type videos.
Okay.
Yeah, since I'm a chemist, and I'm mainly in the lab, whenever he talks to me about the videos that he makes, it kind of goes over my head. Because as a 10-year-old, he gets so excited and he's speaking so fast, and he's like, "Dad, I made this video," and he come watch this video, and I'm like, I don't even know what's going on. But apparently he does. He does follow your channel, and so he's just he's a fully energized young individual that is aspiring to be someone like yourself.
Well, I hope I can serve as a role model. I appreciate that. Ashton, hi to you. Kudos, continue doing what you're doing. I love to see creativity. Dad, you got to encourage him to be creative, so that's good. Hopefully,
I'll certainly try.
He'll watch this video, and that's nice to see. Well, David, listen, I want to thank you for taking the time of the day to do this. Like you've literally, I ticked all the boxes. We went through all the questions that my viewers had and that I had. It's been great. 303 has been very open and transparent through all of this. I deeply, deeply appreciate it, and I'm sure my viewers did as well. Great talk. You were fantastic to talk to. Thanks again, for answering all these questions. If I do have future ones on future videos, I'll let you know for sure. I think everybody appreciates this. The fact that we can have the ability now or the capacity to reach out to companies. Never, like 10 years ago, would I have ever thought that one day I'll be able to talk to the chemists behind the products that I like and that I use in my own detailing arsenal. So big thumbs up to all the 303 team. I know you're alone in there right now, but Joe Palandri and a bunch of others in the management have been great as well. You guys are awesome. Continue to innovate. I'll be looking forward to what you guys come up with next. But thanks, buddy. It's been a pleasure to have you on board. I don't know if you have any final thoughts, but that'll pretty much do it for me, I guess.
Well, I really want to thank you for taking the time out of your day to even do that.
My pleasure.
There's very few people that want to talk to the chemist. And, and so what we found is, first we're isolated within our facility. So it is kind of like being like on a lonely island. And then us usually when there's a problem. And it's like it's nice and it's a moment of relief whenever someone comes and says it's not a problem. We're more curious than anything else. So it's thank you so much for doing this.
My pleasure. Nice change of pace. So we'll talk again soon. And thanks for being on the show, David.
Thank you.
Have a good one.
You too.
Ciao.
Ciao.
So that was a great talk. Thanks again to David from 303 for participating to this great conversation. I think it's important for us to have these conversations as this is a new technology, and I want my viewers to be empowered with all the information possible so you guys can go out there, enjoy detailing your cars, and having all the trust and knowledge and confidence that you guys need to do so. I'll link some other important videos from other channels that are discussing currently the graphene coatings. So there's been Larry from Ammo NYC, Jason from Chicago Auto Pros, and basically any other video I can think of. I'll drop in the description under the video for you guys to check them out. Check out the discussions that are out there. Make your own opinions, guys. What really, really counts is the performance of the product. So bottom line for me, how does the product perform in the real world? If it ticks the boxes of your expectations, then forget about all the drama surrounding this. Focus on the product performance. I can't say that enough. So far, I only present, as you guys know, the products that I truly enjoy from the brands I have respect for and that I have in my own detailing arsenal. So the ones that I present, well, I personally vetted, they work for me. So that's a great starting point. But again, you guys can make your own opinions now thanks to information in these kinds of videos. If you like this, by the way, smash the thumbs up button to show me your support. Which other company's chemist would you guys like me to have a discussion with? Let me know. Drop a comment in the comment section under the video as well, or your thoughts, opinions, and emotions. I always read the comments and I try to respond to them. So guys, thanks for being there. Thanks for watching. And in the meantime, don't forget, keep it tight, keep it clean, and I'll see you on the next one.